fixed on the ground. Okay, so we use this kind of solution to study the loading or moving loading. This is one. Maybe sometime, but be careful. In our model, it seems the spring is connected. Okay, so when the deflection is pushing, okay, pushing, do a reaction. But for this case, in real world, it is a separation of the ground. Actually, no force. It doesn't have a spring connected to the beam. So this we call one-way spring. So this spring is the delta is minus. Okay, in positive delta. So delta minus in positive delta is downward delta positive. So we have the force, reaction force is K. Right? And for delta negative. So this we call the one-way spring. One-way spring. Okay. Understand? Because of this separation, okay, the delta become negative delta, separate. No foundation effect on it, right? So zero force, zero action force. Theoretically, right? So only this like a sleeping spring bed, okay, have a spring really hooking on the bed, okay. But for in real, if you do some soil problem, it's one-way spring. For real soil problem, contact problem, okay. So when the beam separates soil, no, it's a free beam, okay. So if you write programs, you should do some judgment. See the delta KW is separation or contact. I think this is already you can find out for the real case. In this part, it is beam on elastic foundation. But for this, it's a pure beam. Okay. Because the reaction force upward to some homework, right? You don't know. Yeah. So once you know all the things, you can do a lot of the engineering consulting. But you have in mind, okay? You know, right? So one-way spring. Okay. Yeah. Separation. No? Here, beam is an EI. Gotta be force zero. Something, right? Q separation. Right. So in this part, the Goldman equation is not the same as this one. Maybe you need to do some superposition. So that's why we started infinite load. You see, if infinite load beam, with any local loading, maybe you still have a condition with some part separation, right? And there is separation for the inflection point. So some part here will separate. Is that what I mean? So maybe we just focus. Maybe this part is not very big, okay? But how to say? If it's a very soft beam, probably inflection point is very big. Okay? And this part is form, and we have a reaction here. So you can try to use the finite element code, the contact with contact analysis capability. You can put a beam with a one-way spring. Say if separation, see what the solution will be. Okay. If you guys have an abacus or you have some dynamic curve, you can see this problem. Okay. See the separation or the contact zone or the separation and termination. Yeah, I don't know. I don't have the answer. Think about it. It's finite density. But we have two loads, P and P, two loads. Each one have a distance C away from the end, which is I. And so this solution will same as the one is equal to and here P0 N0 P0 okay. For this case, I have M, E, and we have V, A, V, E, and for this loading, I have M, V, and VB. NA coming from VA. Now let's here is symmetry problem. We only did one side. Okay. So we make the NP plus NP double prime equal to 0. And V B prime V B double prime equal to 0. And satisfy the end condition. Okay, so let's solve. And P0 and M0. How much P0, M0 I have to put into here to cancel the effect, internal force due to this 2P. Okay? This one different from the previous one. We have 2P. Okay? So now our M B prime will come from one is I'm on the right hand side of C distance, and I have L distance over this L minus C distance from the P distance. Okay, so my B prime is equal to P over 4 beta phi beta C. Okay, I'm a C distance from this P, and the plus P over 4 beta phi beta L minus C. And shear, the B prime equal to the distance from that one. The minus shear is a minus half P with theta, beta C minus P over 2 theta, beta, L minus C. Right? Easy. Same as the idea as before. Right? Now, difficult part. And B double prime. Okay. First one from the. Oh, I use. Sorry. I use okay. Q0. My notes. So that will be. This one, this Q will be on the shear loading on this side. We change the sign. Right? So this will be Q0. Yeah. Shear should change the sign. No, moment. Sorry, moment is this one. Moment from P on this side is same. I didn't change sign. That would be P0 over 4 beta phi 0. And the plus, I'm distance from the P0, L distance, right? P0 over 4 beta phi beta L. Then, from the moment of this one, I'm on the left side.